In the last video, we looked at y equals 0.8 to the power of x. And when you graph it, it will look something like this. It will cross over at 1 because 0.8 to the power of 0 is 1. So you know it crosses here. And the thing is, as x increases, this thing here heads towards 0. Okay, I'm not very good at drawing. It's really hard to draw curves, something like this. Okay, so here, as x increases, the y value of this line here will head towards 0. And in this video, we're going to investigate what happens when you increase x in this direction. It turns out to be something like this. No, not like that. A lot steeper. Okay. Well, in this video, let's investigate what happens when you increase when x is minus something. Okay, so let's look at this. Y equals 0.8 x. Now, what happens when you put, let's put minus 3 in there. So let's see what happens when we have something like this to the power of minus 3. Now, the minute you see a minus 3 like this, 0.8 to the power of minus 3, well, immediately jump to, inside your mind, jump to something like this, 0.8 to the power of 3. Okay, this here is the same as this. I've already explained this in the indices section. In the indices section. So if you don't understand this bit, then watch this chapter. Okay. Well, the minute you see something like this, y equals 0.8 to the power of minus 3, immediately jump to this 1 over 0.8 to the power of 3. Now, here's the thing. If you have 1 divided by, let's say, a number smaller. Well, if you divide by a big number, let's say this is big, okay? If you divide by a big number, 1 divided by a big number, the answer will be very small. Now, if you have 1 divided by, let's say, 0.00023, say, a really small number, the overall answer would be big, very big. Okay. I know this bit here is strange. Just remember this thing. Suppose you have 10 sweets. Okay. 10 to 6, 7, 8, 9, 10. If you have, let's say, 5 people, 10 divided by 5 people. Hang on. 10 divided by 5 people. You're going to have 2 sweets each. Okay. If you have 10 divided by, hang on. If you have 10 divided by 2 people, then each person will have 5 sweets. If you have 10 sweets and then you divide by 1 person, each person will have 10 sweets. Now, this is the weird part. If you divide 10 sweets, if you divide it by, let's say, a half, whatever that means, divided by a half, the half will have 20 sweets. I know it's weird. Just well, accept it. If you have 10 sweets and then you divide it by a quarter of a person, whatever that means, this quarter here will have 40. Can you see this? This 40 here is bigger than the 10. So my point is, when you have 1 divided by a really small number, so 0.0037, say, the overall answer here would be big. Okay, well, watch this. Hang on. 1 hand clear this. 1 let's do 1 divided by 0.0000269 whatever. 1 divided by a really small number is 37,313. So you can see that this is really big. So when you have a 1 over a 0.0000 whatever, this number gets bigger. And look at this here. Let's say 0. Divided by 0.8 here, and then you have 1 divided by 0.00008 here. Let's just say that this overall number here, the answer to this thing here, is a lot bigger than this. You see, as you make this smaller, the overall, the answer here would be a lot bigger. The smaller this thing is, the bigger the answer will be. I know it's weird. Just accept it. Okay. So let's look at this here. We are trying to investigate y equals 0.8 to the power of x. Okay. In the positive direction, well, hopefully you would have understand. In the positive direction here, I've covered that in the previous video. So it goes down. So when you put 0 here into this x here, it will become 1. Okay, because 0.8 to the power of 0 is 1. If you put 4 into this x here, 0.8 to the power of 4. I've worked it out on the calculator. It's 0.41. Roughly that. Okay. If you put let's say 10 into this x here, it will be 0.8 to the power of 10, which is around about here. Okay, and then plot this. So when x is 0, this thing here is 1, so it's here. Okay, when x is 2, well, let's plot it to be here. Okay, when x is 4, we'll plot this number here. And then and so on. So this figure here, 6 here. When x is 8, plot this figure here. When x is 10, plot this figure here. Okay. So you could join up like this. Okay. And the thing now jump to my remember, we are investigating y equals 0.8 to the power of x. When you try and investigate a line, create a table like this, and then select lots of values here. So increase x in a positive direction, and then go in this direction for x. So hang on, y equals 0.8 to the power of x. So here, put the minus 2 into this x here. Okay, so you would have y equals 0.8 to the power of minus 2. And the minute you get minus 2 here, immediately jump to 1 over 0.8 squared. Now, the reason why you can do this is, well, I explained this in the indices section, in the indices chapter. So if you don't understand this bit, you might have to watch watch one of the previous videos. So from here we jump to here. Now this thing here, we'll punch into a calculator. This thing here will give us this. Okay, and then we would do this. Hang on, y equals 0.8 x here, and then we would put minus 4 into this x here. So this would become y equals 0.8 to the power of minus 4. Now this minus 4 is really hard to understand, so immediately jump to this 0.8 to the power of 4. You see, earlier when we were here, it was 1 over 0.8 to squared here. You see this number here. If you look at this number here, this number, the denominator here, for this one here, it's a lot smaller than this one here. Now, if this thing is a lot smaller than this, then the overall number here, this overall number here is bigger than this overall number here. I know it's weird, okay? So let me do this bit here again. But by the way, if you try and plot this here, it would take you to this point here, okay? And then if you try and plot this point, if you try and plot this point here, this is minus 2. It takes you to here, okay? Now if you do minus 4, it would take you to here, okay? And the thing is, this thing here is a lot bigger than this thing here. Hang on, let me just draw this line in here. It will look something like this. Oh, doesn't cross over. Hang on. Something like that. Okay. It's hard to draw a curve, but I just want you to look at this bit here and this bit here. The thing is, as you go towards minus infinity, well, as you head to the left, it gets bigger and bigger. You see, it gets bigger here. It gets bigger and it gets bigger. And the reason for that is right there. The reason for that is let's look at this bit here. This is 1 over, in effect, 1 over 0.8 squared. Let's have a look at this thing here. Okay, 1 over 0.8 to the power of 8. You see, let's just look at this bubble here and this bubble here. This bubble here, it's a lot smaller than this bubble here. The thing is, the smaller this bubble is, the bigger the overall thing is, because when you have let's say 1 over 0.00001 and compare it to 1 over let's say 0.1, you see, because this is smaller, the overall thing here would be bigger than this thing here. Just accept it. Or play around with it. Get a calculator and play around with this. But and anyway, overall, as you go in this direction, it gets bigger and bigger because 1 over this bottom number here. Because as you go in this direction, this number gets smaller. Now, because this number here gets smaller, the overall thing gets bigger and bigger and bigger. Well, just up to this stage, just accept that if you have something like this, it will look like this. Okay. Yeah, and it's also true if you have say 0.2, it will also be it will follow the similar path. If you have something like 3 to the power of x, because 3 is bigger than 1, it's going to grow each time. It's going to grow. So with 3, it's going to grow. Okay, with something that's smaller than 1, it's going to get smaller. It's going to decay. It's going to get smaller and smaller. Well, when it's let's say y equals 7 to the power of x, because this number here is bigger than 1, it's going to grow and grow and grow. When you have y equals 0.let's say 6 to the power of x, because this thing here is smaller than 1, it's going to get smaller and smaller and smaller. It's going to decay, if you like. Well, it's going to get smaller and smaller. Okay, so and then the weird thing is when you're looking at this here, if you go in the negative direction, it grows. It's going to get bigger and bigger as you head in this direction. But if you go in the positive direction, for this case here, it's going to decay. It's going to get smaller and smaller and smaller. Okay. Up to this stage, accept it, I guess.